So 3-4 is something that we've already learned in Algebra 1, so we're just going to do a quick little review. It's about the quadratic equation. In all the previous sections when we've been factoring, we've been able to use the x method, or we could have one of those special factoring situations, but the quadratic equation is for a foolproof method. This is for the infactorable, if you will. And so what we're going to do is we're going to base it off of our equation, which is up here at the very top. And I just want to point out a couple things, that the a value is always going to be in front of my x squared. And of course, if I didn't have an x squared, it would be a 0. But we have our a value, and we can see that it's in our formula here and here. And then we have our b value. Well, that's going to be in the front and also in the front underneath our radical. And then finally we have our c, which is the number that's completely by itself. It doesn't have any variables of any sort nearby, and that is going to be at the end of our radical. And so knowing this formula here is extremely important. So if we go to example 1.2a on the right-hand side. I'm going out of order just so that we can start with something a little bit easier before we get to something complicated. But we're looking for the values in front, or the a value in front of our x squared. And if we don't see it, it's an understood 1. Our b value is going to be the number in front of x. And the reason I'm just reiterating this is because sometimes things are going to be out of order. So in this particular case, it is going in order, but if it weren't, again, just know that your b value is going to be with your x. So this is going to be a -4, and we know it's going to be a -4 because you always carry the sign of whatever you need. And so that means c would be 3. Now that we have all of these values sort of identified, we can go ahead and plug them into our formula, starting with b. A quick note is that the equation for the quadratic equation has a -b right off the bat. So I'm going to put it as negative parenthesis, and then I'm plugging in my -4. All right, so just because the formula already has a negative and our b value is negative, we're not going to just forget one of them because we think it is already accounted for in the equation. When you're doing this, please make sure you are incorporating all of the numbers exactly as you see them. So this is going to be a negative parenthesis -4, and then we can keep going. Plus or minus the square root of -4 squared minus 4 times a times c. All right, and all of that's going to be over 2a being that one value as I mentioned before. So we're going to go ahead and try to multiply as much as we can. At the front, those two negatives become a positive, and we can carry that plus or minus square root. -4 squared is going to be 16, and that 4 times 1 times 3 is going to be a -12. All that's going to be 2 all over that. Everything's going to be over 2, sorry. And we can do one more thing. Now that we're done multiplying, we can see that 16 and 12 actually subtract. So it's going to be 4 plus or minus 4 over 2. Now that I've completely simplified everything under my radical, I can go ahead and see that the square root of 4 is in fact a perfect square, and it equals 2. So my answers will be 4 plus or minus 2 over 2. And now I can take a moment and just figure this out with a calculator or in my own head, but I'm going to start off by saying 4 plus 2, 6, divided by 2 is 3. And then 4 minus 2, which is 2, divided by 2 is 1. And we can plug this into a calculator and get, just reaffirm that this is in fact the answer. When you plug in 3 for x, you should end up with 0. And when you plug in 1 for x, you will also get a 0. So that is a very straightforward, beautiful number, easy, way to go, just woohoo. So what if it's not as pretty? Well, every single trinomial is going to start off basically the same. So off to the left-hand side, I'm labeling my a, my b, and my c. All right, that's 1, -6, and 4. I'm going to plug it in. Again, my equation starts off with a negative, and then in parentheses, I'll plug in the -6. All right, so we're plugging in everything. a times c over 2 times 1. And we, again, have two negatives, which become positive. Negative 6 squared, it says 36, minus 4 times 1 times 4, which is 16, all of that over 2. Again, I can see I can subtract under the radical to get 20, and the square root of 20 can actually be reduced. So if you are getting used to simplifying radicals, then you could probably guess what this is going to be pretty quickly. But if you are still a little unsure, you can always use that birthday cake method where you put the radical as the base, and we are going to divide by the prime numbers, just like our factor tree. And we see that we have a pair of 2's, and when you have that pair, that gets to leave the radical, and whatever you don't circle stays under the radical. So this is going to be rewritten as 6 plus or minus 2 times the square root of 5 over 2. Now, I could leave it like this. However, I can actually take it a step further, because if you notice, all of the numbers that are outside of, the radical or anything like that are actually divisible by 2. Everything's even. So what I'm going to do is I'm going to take that 2 at the bottom, and I'm going to divide it with the 6 and with the 2 right here. So 6 divided by 2 is going to give me 3. Carry the plus or minus symbol. And then 2 divided by 2 is 1, so I could put that in front of my radical, but I'm just going to leave it as the square root of 5, because the textbook does not like it when you put a 1 in front of the radical, and it'll count your answer wrong on big ideas. So this is what you would do with our quadratic equation, and we had a more complicated answer, or complicated solution, I should say, and what you would have to do if you were reducing. So the next thing we're going to do is talk about the discriminant. So the discriminant is the portion of the quadratic equation that's underneath the radical. And it might seem a little counterintuitive to only take off a piece of the quadratic equation, which is our foolproof method, except for the fact that sometimes we don't really need to be finding the solutions. We just need to find, what type of solutions we'll get. So typically in problems that I've seen this in, it's been like on the SAT where they have about 5 or 6 equations, and they say which of these solutions are real numbers. And so you could use the quadratic equation for all 6 of the equations, but in reality they're not asking you, well, what are the solutions? They're just asking, what type of solutions do you have? Are they real? Are they imaginary? And so we can discover that very quickly without doing the whole quadratic formula by just using the piece under the radical, because the radical has the most limitations in that formula. If it's a positive number, so let's say, let's fill this in, that portion under the radical is called your discriminant, okay? And it is that b squared minus 4ac, that's the portion under the radical, that I mentioned before. And so if it is positive, so I'm going to rewrite it again, and I suggest you do as well so that you get used to this formula and you don't forget it. But if it is bigger than 0, that means it's positive. Okay, that's like having a square root of 25. Our answers are positive and negative 5. Our answers are 2 real solutions. And the whole purpose of this is to discover, well, what type of solutions are they? Are they real or are they imaginary? So on my SAT question, instead of doing the quadratic formula 6 times, I'm going to use the discriminant 6 times. And it's going to tell me, oh, if it's positive, then it is a real solution. So that would be part of my answer. If we had it where it was equal to 0, so obviously that would be 0 under the radical, well, then that's just 0. And the positive and negative that we have in front of it, technically, from the quadratic equation. Remember, the quadratic equation, I'm going to write it off here so we can clearly see. Negative b plus or minus square root of b squared minus 4ac, see, all of that over 2a. So again, I'm just talking about this portion with the discriminant, but since it's part of that quadratic equation, of course I could have the positive and negative, but if it's 0 under the radical, then positive or negative does not affect 0, because 0 is neither positive nor negative. So in this particular case, we would have 1 real solution. Okay, and then the third case, so it's still part of the real solution, but in the third case is when our discriminant b squared minus 4ac is less than 0 or it's negative. So this would be an instance where we had like square root of negative 5. And because we have a negative under the square root, it's going to leave as the imaginary number, and then we can take the square root of 25. So our answer would be positive and negative 5i. So let's do a couple of examples. So in the example below, we're going to start with probably the most complicated and just get easier and easier and easier. But we're going to start with our 2.1a on the left-hand side. It says find the discriminant and determine the number and type of solutions. And it says part A is 25x squared minus 8 equals 12x minus 4. So the first thing we have to do is actually bring over everything to the same side. So I'm going to bring all the left-hand numbers over, all the right-hand numbers over to the left. And so I'm going to add 4 on both sides, and I have like terms here with this 8. And I'm also going to bring over the 12, and it doesn't have any like terms, so we're just going to put it in front for a second so that I know that it's not combining with any like terms. And so I should end up with a 25x squared minus 4 minus 12x equals 0. And so really what I did is I did subtract that 12x, but I just tacked it on at the end. And so as we can see, we have some things that are out of order, but that's okay. We know what to do. Our a value is always with the x squared, so that's going to be the 25. The b value is always with the x, so even though it's not next, it's at the end, I can still find it. It's going to be a negative 12. And then the number by itself is c, so that's negative 4. Once I'm done with that, I'm going to plug it into my discriminant, which is b squared minus 4ac. So we plug in, and it says b comes first, which is our negative 12. So it's going to be negative 12 squared minus 4, because that's part of my equation. It's just part of the formula, times a, 25, times c, which is negative 4. The first portion is going to give me 144. And then the second portion is going to give me a positive 400, combine everything to get 544. And so our discriminant is positive. So if I refer back to my notes on the just above this, then I can see that my answer is this is going to give me 2 real solutions. It's not telling me what the solutions are. It's just telling me that whatever they are, they're going to be real numbers. So the one beneath that, we have a negative x squared plus 4x equals 13. Again, we have our information separated, so I'm going to bring over that 13 by subtracting. It does not have any like terms, so it's just going to sit at the very end, and it should say equals 0. So now my a value is negative 1, b is a positive 4, and again, it's a negative 1 because if you see right here, I have this negative, so that's how I know it's a negative 1 this time as opposed to a positive 1. And then my c value is going to be equals to negative 13. Plug that into our formula, and we should get a 4 squared minus 4 times negative 1 times negative 13. So the first portion is going to be 16, and then negative times negative times negative is still negative, but 4 times 13 is going to be 52. So 11 minus, not 11, but 16 minus 52 is going to give me a negative 36. And from our notes, we know that this is going to be 2 imaginary solutions. 2 imaginary solutions. And so again, we are not really concerned about what the discriminant is. So we have this 54 and the 36, but that's not what the answer is. Those numbers are merely used to help us figure out, well, what type of solutions are we going to get? So we're going to go over to 2.2a really fast so that we can have just a little bit more variety. Again, I said we were going to start with the hardest and get easier. This one, everything's on the same side. It equals 0, so we can go ahead and get started. A is going to be 1, B is 12, and C is 36. Plug it into our equation for 12 squared minus 4 times 1 times 36. Again, this is based off of our b squared minus 4ac, and we're taking each one and plugging them in. Okay, so I'm just showing you what that is. Okay, so now I can say, well, 12 squared is 144, and then 4 times 36 is also 144, so If we subtract the 2, we get 0. Again, with our notes, this tells us that if we have a 0 as the discriminant, we have one real solution. And so this process is very straightforward, and it helps us expedite our process and find answers a lot quicker. So the last example is really nice because it's a nice word problem, and I know most of you guys are probably rolling your eyes at the idea of a nice word problem. However, it is a really good practical use of what we're doing. If you think about all the things that teachers say concerning, how useful math is, well, this is one of the best examples to see where it can be applied. This can be applied to if you are in construction. It can be applied if you're in interior design. It just extends to a lot of different areas, so it's really nice that way. So here's a really easy scenario that could possibly occur. We have Brooklyn is constructing a frame for an 8-inch by 12-inch photo, and she wants the frame to be the same width all the way around, and the total area of the frame and photo to be 192 square inches. So I'm a visual person, so I'm going to go ahead and draw my picture. Straighten up a little bit, but it's going to be an 8-inch by 12-inch. So, sorry, I'm a perfectionist sometimes. Okay, so here's my photo. I need a border or a frame that goes all the way around it that is the same width on each side. And so this is going to be, since I don't know how wide it is, going to be my X. And so if I look at the very end, it says that my total area is going to be 192 square inches. And it's nice that they told me that because I now know what formula I need to use. I need to use area equals length times width, where area is my 192, and then my length is going to be everything across my photo, including my frame width, which I don't know. So what I'm going to do is I'm going to highlight everything across for my length, and I'm going to say, okay, this X and this 8 and that X, everything across, that's my length. And of course, if we were to orient the photo, it would change, but for this particular example, it's going to be everything across. And then I'm going to add all of that. It'll say X plus 8 plus X. Well, from there I can combine like terms, right? So technically it would be 2X plus 18 or 8, excuse me. And then I can do the same process again for my width. So I'll do my width, and I'll say, okay, well, this X, this 12, and this X are going to be my length or my width of this photo. And so I can combine these three, X plus 12 plus X, and I'll end up with the same thing where I have to add the two sides of the frame. It'll be 2X plus 12. And so from here, I can see I have a binomial times a binomial, which means I need to use FOIL to work this out. So I'm going to carry this down and do my first, which is 4x squared, and my outside, which is 24x, my inside, which is 16x, and my last, which is 96. From here, I can go ahead and combine any like terms that I have. So I'll write like terms, and I'm just putting my my steps off to the side here so that I can just keep things organized. And it's nice because all of these steps are the same across all these types of problem. So I combine my like terms, and I should get a 40x plus 96. The next thing that I have to do, now that I'm done, working out all my parentheses and stuff, is I can't really factor this, or I can't even use the quadratic equation until I make it equal to 0. So I'm going to say set equal to 0, and I'm going to subtract 192 on both sides. 192 is like terms with the 96 because neither of them have that x. And so I will get 0 equals 4x squared plus 40x minus 96. And so from here, I have a choice. I can either go ahead and use the quadratic formula, which is what I've been doing, and I strongly recommend, or I can keep going and factor. Now, personally, I like to factor. It's just my preference. But if you're looking at this and you're like, this is really long and complicated, then take this opportunity and practice the quadratic function or the quadratic equation. So I'm going to continue factoring for my preference, and in order to do that, I need to make my numbers just a little bit smaller, and I'm missing an x. Hold on. I need to fill that in right there. Okay. So I need my numbers to be smaller. So what I'm going to do is I'm going to divide all of my numbers by my leading coefficient, 4. So you're always going to look to see if you can divide out your leading coefficient, which I show here with LC, leading for L, coefficient for C. So we're going to divide everything by 4, because that's our leading coefficient. And we make our numbers smaller, so it's x squared plus 10x minus 24. And now that I've made my number smaller, I don't have to deal with the leading coefficient. I can go ahead and finally factor. And so I'm going to factor using that x method where 10's on top and negative 24 is on the bottom. My factors of 24 are obviously 1 and 24, 2, 12, 3 and 8, 4 and 6. And we'll stop there because there are none left besides 1 and 24. But anyway, I'm looking for a combination that's going to add to the 10, or add or subtract, to the 10, and it's going to multiply and get me a negative 24. Now, it's important to note that I need to multiply to a negative 24 because this tells me that one of my numbers is negative. Not both, not none, but one of my numbers is negative. And it's also important to have that positive 10 up top because that positive 10 tells me that after I combine my my terms with addition or subtraction, I still have a positive 10 left over. So that tells me that my smaller numbers need to be negative, so I'll put those over. And then it's a lot clearer for me to see that I can combine the negative 2 and the 12 and create my factors of x minus 2, x plus 12. From here, nobody goes to the store and says, can I have a frame that's x minus 2 by x plus 12? Like, nobody says that. So we need to solve these by setting them equal to 0, and we should get 2 and negative 12. Now, remember, in a word problem, some answers make sense and some do not. And so the problem or the solution here that doesn't really make sense in a real life scenario is that negative 12, because nobody has a dimension of negative 12. It's just not a thing. So we're going to cross that out, and our answer is going to be x equals 2. Now, I am going to tell you that you have to watch out when it comes to your directions, because some directions say to find the dimensions. And so if you're finding the dimensions, you need to plug in your x value into all of your sides on your frame or whatever you're talking about. Like 4.1 is, or not 4.1, 4.2 is talking about a deck for your pool. So whatever it is, in this particular case, it's a frame. You're going to plug in your x value for all of those positions, and you are going to give an answer as a sentence because it's a real world example. So my length is going to be, again, that 2 plus 8 plus 2. Well, 2 plus 8 is 10, plus 2 again is 12. So this is going to be a 12 by, and I'll do the same thing again for my width. 2 plus 12 is 14, plus 2 again is 16. So this is going to be a 12 by 16 inch frame. All right, and that's my answer if they ask for the dimensions. If they just ask for the width of the frame, though, then all I would have to do is take my x value and say, well, my frame has a 2-inch width, and then that becomes my answer. So just make sure you're watching out for the instructions and how they're asking. Again, you can definitely, at this point, and I'll highlight it for you, but at this point, once you get your equation to equal 0, you could definitely, instead of continuing on into factoring, take a moment and do the quadratic formula, and you should get the exact same answer. So I just want to make sure that you have that, but it should be negative b plus or minus the square root of b squared minus 4ac, and you would have gotten the same exact answers. They would have given you directly 2, negative 12 if you had done that. So it's all based on preference, and I hope that is helpful. And let me know if you have any questions. Have a good day.